it was all we were based on per job. And they were just these long, not apartment complexes. They were townhomes. So just think of like long stretches of townhomes. You know, they're probably like 50 units per cluster.
Yeah.
And
Were you framing? What were you doing?
no, so there's three of us. We would go in and do hang doors, do all the trim, and then we would prime and spray.
Ah,
And we had to be moving ahead of the tile guys, because as soon as tiling came in, then we had to do extra taping. So we always wanted to spray before
yes.
tiling came in and before cabinetry came in,
Right.
because so, and they're right on our tails. So
Right.
anyway, we were working, and I was looking to finish up our last house of a big cluster to get a big, our paycheck. And I
Mm-hmm.
was looking for a strip of wood, and we didn't have this little strip of wood. So I'm rushing the job. I run out and I grab a thicker strip of trim, and I'm running it on the table saw, and then one of the guys I'm working with comes out. He's like, Sandy, I found some, and he's holding up a piece of, it's like a 1/4 inch piece of trim. And I look up, and as soon as I look up, I just get, blood splatter
Oh,
everywhere. So just that instant second of guiding through,
oh,
and
oh my
it
God.
came right across my three fingers, and I looked at him, and it was bad. I had them all. It was bad.
You
We
had them
wrapped it
off.
up.
Oh my God.
Yep. Most of them they were still attached. They were not, I had to turn
Yes.
my hand around to see two of them, but I was able to get in. We called 911. What was funny about this at the time is a guy comes over on his skid steer, and he's like, "You cut your fingers off?" And I said, "Yeah, I think so." And he raised his hand up, and he goes, "Yeah, welcome to the club."
Oh my gosh.
And he said, "You're better off put them on ice and drive to the hospital. It'll be faster." So we got in the truck, we got to the hospital, and I was able to get into a surgery that day. They had their hand specialist was on call, so
Oh,
we went in.
thank
Did a four
goodness.
4 hour reconstructive surgery. So on the topic of, and I bring it up because I see in your background you've got your sign.
Yes.
And I don't know if everyone in the audience can see it, but it says 1,264 days since, I'm assuming, your last accident.
Yes. Yes. And I was the star of my last accident, let me tell you. So what happened to me was I had on steel-toed boots, which I do now, and I had on all my gear. But I had turned with a heavy jaw vise, a vice jaw, and I had turned and I hit the side of this, and it knocked it out of my hands, and it came in and it hit the top portion of my foot that the steel toe doesn't cover.
Yeah.
And I tell you what, I couldn't walk for 2 or 3 days on my left foot. It was so swollen, and but there was it was all internal bleeding, but it was a lost time accident. I had to go to the doctor, right? And so I had to. What really upset me was I had to set that thing back to zero.
Yeah.
And now and that was 1,264 days ago. So
That was 4 years
that
ago, 3.5 years ago. Wow.
yeah. So that's what it is, and that record is very important in a shop too. By the way, usually everybody can see that, and they're well aware of, that we look and we consider safety to be very, very important.
Yeah,
So
for
that
sure, 100%.
so my hard hat, not going to be wearing it today only because I've got on this.
Okay.
So I think I'm going to mention that when we go live. Just
Yeah.
okay.
Well, I think we're live now, John. Actually,
Oh, okay.
let's
Okay.
welcome our guests. So everyone, thanks for tuning in today on SolidWorks Live Design. Super awesome special guest, John Milbery, who's, if you don't know this guy, he's a legend in the SolidWorks community, in the SolidWorks world. He's been with Dassault and SolidWorks pretty much since day one, right? 25 years, I want to say, John. Is that correct?
That's correct. Yeah.
Wow.
25
So
glorious years.
that's amazing. And along your time, you're down in the South in Texas. You've been known for kind of the oil and gas industry expert, but you're also our in-house machining cam guru. So where are you coming live from today? This looks like a legit production shop.
It well, it is in a way. I mean, it's coming from my shop, which is located in Frisco, Texas, and which is a northern suburb of the Dallas-Fort Worth area. And I've lived here in this area probably most of my life, and I love it here. I'm a native Texan, and I love it. And I want to welcome everybody to my machine shop today. This is called Milbery Machine Shop, and I'd love to have you as my guest.
Well, we appreciate having you here. We're excited to learn a lot about machining operations. For everyone that's joining us today, I see Jason in the audience. What's up, Jason? Always a pleasure to see you.
Hey, Jason.
owe you a phone call, so I'll give you a call back here today. Tomorrow, we'll touch base. Anyone else? Where are you guys coming from? You know, John's in Texas, Frisco, Texas. I'm coming from snowy Eagan, Minnesota. We're getting a good dumping of snow this morning, which I'm excited about. But jump in the chat. Let me know where you guys are chiming in. And as we're going through on live design, you know, ask questions. John is an industry expert. You know, we'll feed those over to John, and we'll stop him in his tracks and see if he can answer for you. But with that, let's turn it over to you, John. What do you have for us today? I'm super excited to see you dive in.
Well, what I'm actually going to do is I'm building a piece of equipment that I actually need to be able to do live streaming and webinars like we're doing today. And so you can see that I've got a camera feed on the side of my machine tool. We've got a camera feed that you're seeing me right now, but I want to create yet a third camera feed. And to do that, I'm going to use my iPhone. But the problem is I've got to get my iPhone connected to a tripod in order to, you know, shoot the camera and have it live stream. So what we're doing today is we're building just such a device. And my iPhone is going to sit directly in this cradle that you see. Can you see that? Mm-hmm. And what I'm going to do is this is what we're going to machine today out of a solid billet of aluminum. And what the iPhone is going to sit inside of here. And on the back side, we're going to machine away the carrier, and we're going to have a camera screw mount right here. It's a standard camera mount that I'm going to be able to connect to a tripod. And that will give me yet another streaming view. So I built one of these. I'm going to build 3 of them because they're prototypes, and we should be good. They should work, and I should be able to have all of the feeds that I want at any given time in the machine shop.
So, John, for some of the folks in the crowd, probably, you know, in the design background, I'm guessing you used Solidworks for the design?
Of course, absolutely. Yes, I use Solidworks to lay it up, and also connected a tripod and a couple other connecting pieces to make sure that it all worked before we cut metal.
Okay. What's aluminum? Is that for the weight? Is that kind of the primary?
Oh, sure. It's super lightweight. It's super strong, and it's for me to prototype on this machine. Aluminum's the easiest thing for me to machine. So aluminum on this machine is just fantastic. It's a 10,000 RPM machine, and it's got enough horsepower to cut through this aluminum pretty well. In fact, we're going to use some high-speed machining techniques here in a while, and you'll get to see what that looks like and how it feels.
Awesome.
Yeah. So should we get started?
Let's do it.
Okay. So I'm going to turn my back to you, but you should be able to see me here on the other camera. What we're going to do is we're going to load up this blank piece of aluminum, and then we're going to indicate it in. What we're going to do is we're going to set the XYZ location over here at this lower left corner. And that's so that the NC toolpaths that I've got are expecting their XYZ0 to be at this left corner, okay? So what I'm going to do is I'm going to start, and you're going to see here on this other feed, I'm going to start by placing the aluminum inside of a very special type of jaw that we call a talon grip. What's interesting about these grips, I don't know if you can see right here, but this grip is going to grip just about 1/16 of the material. What's really cool about that is that I can machine all the different sides except for the bottom, all in one shot. And what I'll be able to do then, after on the second stage of machining, on the second Gcode file, is I can remove that carrier, and I've got the finished part.
So John, you're doing this as I learned this from we talked with Titan,
Yeah.
CNC's a Titan, awesome guy, Titan Gilroy, and I
Yeah.
learned about multi-step machining processes. So you're doing this in a two-step process. Is that accurate to say?
Yes, and what you'll find is when you're using a 3-axis vertical mill, doing multiple setups is pretty common, because you got to get the underside of the part. Now, typically, that's why people go to a 5-axis machine tool, so they could do this all in a single, operation and setup.
Right. So less operations, cheaper to manufacture. Was that?
Oh, yeah, absolutely.
Kind of the angle. Okay.
Oh, absolutely. It makes a heck of a difference. So what I'm going to do now is I'm going to tighten up these talon grips. And there's a notch in the grip that I'm looking at. And what I want to do is I want to make the gap in that notch disappear. Once I've done that, this little tiny grip exerts so much power and so much gripping power that I can do very deep high-speed machining cuts, and this will not move. It will stay totally stationary. So we've got our part in there. The next part is to go ahead and we're going to use our probe that you see here. And this probe is one way that we can set our corner XYZ0 for G54.
So again, here is just kind of telling the machine where exactly your workpiece is located in there.
Yes.
So it knows, right? It needs that base reference of 0, 0, 0 coordinates so it can understand X, Y, and Z position.
Yes, it does. Now what I'm doing is I'm using a manual jog to jog this into position. And I can actually do this visually here with this jogger. And it is a great tool. So now that I've got this where I can now find, I'm off at a kind of an angle for both the X and the Y. What I'm going to be able to do is come over to my probe routines, and I can do a special probe routine to find the corner. And we're going to go ahead and we're going to do that. You can see it find X, and it'll come back and it'll touch off and it'll find Y. So that's really cool. X and Y have been found. Now what I'm going to have to do is I'm going to move this up in Z, and we are just going to slide this over. So on X, we're going to come on over. In Y, we're going to come over a little bit as well. And this will be good enough. So what we're going to do is we're going to use a special probe routine now to come down and touch off on the top of this.
Okay.
And it will find Z0.
Got it. So Jason says, well, it's 63 in New York, which, Jason, I'm sending you the snow. It's coming your way, so enjoy it now. But he also said G54 equals no place like home. I know of Gcode, but I don't know Gcode. What does G54 mean?
Well, G54 sets, it's a work coordinate system. And you're probably not going to be able to see this very well, but if I come over to offsets and go up to work coordinate, my G54, this is the location from where the machine knows its XYZ0 and where I'm telling it the new XYZ0 is at.
Okay.
And so for me, I could program everything from a bizarre place up in space, up here, which is where XYZ0 is on the machine. But in reality, it wouldn't make any sense. I want to do it off this corner, right?
Sure.
So that's why we're able to take these coordinate systems and float them around. And typically on a Fennec dialect type of controller, you've got these G54s, 55, 56, 57, 58, 59, and up to then 59.1, 2, and 3. And the reason for that is because doing a very complex part, I may want to come over here with the probe interactively during the machining and actually start to set and measure and on the fly create new coordinate systems.
Oh, interesting. Okay.
Yeah, so it can get really, really complex. So what I'm going to do now is we're just going to go ahead and go home. And Jason said there's no place like home. On these particular machines, you can use a G53 to get home, or you can use a G30. So out of the box, a Tormach's G30 is a G53 X0Y0Z0. So what I'm going to do is I'm going to MDI in a G30. And you can see that the machine tool is now going to return to that relative home position.
Got it.
Okay. So now what we're going to do is we're going to open this up more. I'm going to remove the probe, but to do that, I'm going to go over here and I'm going to start my compressor for just a moment. So hold on.
Okay. So while John's doing that, feel free, you guys, as in the chat, chime in if you have questions. Again, John's been doing this for a very long time, super knowledgeable, happy to answer anything. Or as we go along, and if you have a story or a tip to share, maybe folks that are getting new into machining, learning, 3-axis, 4 or 5-axis Gcode for the first time, feel free to share those as well. We're here to kind of chat and just, communicate and talk about things we geek out on. So happy to hear it.
So we're just removing. What I'm going to do is I'm going to open up. And now we've got the probe. I'm going to place the probe over here. And we are now going to use the shell mill, or what we would call a face-off tool. And it's going to face and skim and clean up this entire surface so it's totally level, totally clean. And this will become my very top of the part.
I was going to ask that earlier, John, because I know you clamped it in there, talk about really holding that into position, and I can see it's important that it stays in that position throughout the machining process. So good work holding tools. As you know, I got to spend some time over at Kurt Work Holdings not too long ago and learn more about that. Super interesting. But I didn't know about the leveling, so you don't have to worry too much about maybe your material supplier or how that stock billet comes in, how flat that is. You're going to actually go through and clean that up.
That's correct.
Got it.
And that's the thing about it is, right, we true that up, and that's exactly what we do. So what I'm going to do now is I'm going to load the actual Gcode. And we'll just double click that and we'll load it. And one of the things, I don't know if you can see this, but you can see in the controller that I actually see the projected tool path.
Okay.
And it's giving me a lot of critical dimensions from the edge of my machining envelope. And this is really cool because I can look at this and I know that all my machine is within the restricted machining envelope of the machine. In fact, the Tormach is advanced enough to where if it sees anything that runs outside that limit, it'll throw an error the moment that I load the tape or the Gcode file.
So we going back in kind of the history a little bit, I know traditionally speaking, when these 3-axis machines became more available, the technology was there. With Gcode was the standard you needed to learn. Jason mentioned out there, he knows Gcode, Gcode. I don't. Yeah. Today, is that still a requirement? I know it's probably a good foundational piece, but what about some of these other like CAM softwares, like Solidworks CAM's available? How does that help me get a part machined?
Well, ultimately, what happens is that if I didn't have SolidWorks CAM or if I didn't have Delmia NC to create toolpaths, what I'd have to do is I'd have to use a calculator and look at a blueprint and what we would call manually coding. It would require trigonometry and some other skill sets. And it's very prone to error, right? Because you're just making all these calculations. And it takes quite a while. And on some things, especially on 3-axis contouring, it's almost impossible to manually program that. So what we do is we have CAM softwares like SolidWorks CAM or Delmia NC, which what they actually do is I actually will set the same XYZ0 in my CAM system right here at this corner. And then what we'll do is I'll create what's called tool paths. So I'll actually have a tool path come down with a cutter that I choose, and it goes back and forth, and it machines the part. In fact, it looks just like what you see on the screen.
Okay.
And then what happens is that then the tricky part happens. We go through a post-processor, and the post-processor converts that data that we're seeing on the screen in the CAM system to Gcode.
Oh, okay.
Okay.
Yeah, you hear post-processors, and I wasn't sure if that was the seeing the toolpath, but that's the actual conversion process.
It is. It's the conversion process, and almost all different machine tool controllers require a different kind of form of Gcode.
Okay.
And even on the same controller between different shops, they'll want Gcode to be flavored or output slightly different based on how they're going to run the machine. So it's getting the post-processor right is always a tricky thing, but in the end, once you've got it right, you can completely forget about it. Everything just flows out of the code. We're ready to machine. So this very first one, we're going to run a little over 5,000 RPM. Let me turn off this compressor. Can you guys hear it? Can you hear the compressor?
A little bit, not too bad.
A little bit? Yeah. Okay, it's not too bad? Okay. What we're going to do, I'm going to turn it off anyways a sec. There, it'll stop here in a second. What we're going to do is we're going to machine about 45 thousandths depth of cut on the top of this aluminum. And we're going to use the shell mill, which is 1.5 inch cutter that has multiple carbide inserts in it. And so again, the idea is to get this nice and flat and clean. So without further ado, let's give it a shot. Okay. I'm going to come over to the controller and go into single block. And right now, since this is the first portion that I've run, what I want to do is I want to be extra careful as I approach the part. Okay, now this is just important. Make sure that the G54 that I've just set up is correct and there wasn't an error. So what I'm going to do is I approach the part in Z. I'm going to look at my distance to go, digital readout. When I get about 1 inch above the part, I'm going to pause it. And I'm going to visually check to make sure that it's 1 inch above the part. And if it is, then I feel pretty good about the G54 taking and everything being in the right place. Okay?
So what if you didn't? What if you fudged that decimal point over one? Would your machine just keep pushing into the part as it's trying to find the? That's probably not a good thing.
It's what we call a wreck, and it's not a good thing. Because a lot of times, depending on what it is, you've got to rebuild your machine. You know, you've got to have experts come out and do it. Now with Tormach is great because when you buy these machines, you build them from scratch. They're like a big Heath kit. They arrive in crates, and you put it all together. And by the time you finish putting it together, you pretty much know how to fix any wreck that you might cause in the future. Knock on wood, I haven't done that yet. So let's go ahead and let's approach the part. And let me show you what I mean about being safe and getting within 1 inch of the top of that stock, okay?
Oh, now I'm nervous.
Yeah. Well, you know what? And all machinists on that very first approach do get a little nervous.
I bet. I can imagine, some of these big Swiss machines, and that this little part as a new guy, I'd be sweating. Yeah.
So the first thing we're going to do is turn on the spindle. I'm going to turn that on at 6,800 RPMs. Okay. And now you can see the Gcode. We're going to splash the coolant on, but I'm going to take it off. Okay. See, as we're approaching the part, what I've got is I've got a digital readout that says distance to go 2.7525, and I can already tell I'm not going to crash into the part. So this is great. I'm just going to let the max velocity come up. And right here, I should be around about 1 inch above the part. And I can look at it. And I can go, I feel comfortable with that.
Yeah, that looks good.
That is cool.
From here, looks good too.
So we're going to cut this dry for this so that you can actually see what's going on with the cutter. So I'm not going to put any coolant on so you get a good visual. Okay, so we're going to take it at a single block. We're going to go to max velocity, feed, and RPM, all at 100% of programmed rate. And we're just going to hit cycle start.
All right. So John, another question is, you talk about the rate, right? The RPM that you're doing. You're also moving the workpiece. I'm going back and I'm thinking about this carbide tool. I'm guessing these things aren't something that you pick up at your local Menards or Home Depot for cheap.
No.
So how do you? There's got to be a balance there in terms of how fast and how deep we're moving the tool and the lifespan of that. Is that just industry knowledge, or how do you kind of figure that out?
It's, well, the very first, and you're absolutely right. The first thing I do is I ask the tooling manufacturer for their recommendations. And they almost always publish their recommendations. Okay. And it's a balance between great performance and tool life. One of the things you really want to do is make sure that you get as much life out of your tool as possible. And if you can run really, really fast and make a part in half the time, but every time your tooling needs to be changed, you're not helping yourself.
Right. It's like running a chainsaw. You can gently let it do the work, or you can push it through. For the 30 seconds, I'd rather have a little longer chain life.
That is a greater analogy. That's a great analogy.
Makes total sense.
So you can see now that this is a multi-pass operation. It's got about a 70% step over ratio. And again, it's a 1.5 inch diameter shell mill or face mill. And I don't know if you can see in the video, but it's producing a very high polish. It's just a super kind of a mirror finish on top of it.
Yeah, we can see it here. It looks really clean. Okay.
It does, yeah.
So question on this operation, and going back to that, we're leveling, we're taking off this first top of when I'm designing a part and I'm designing for known stock materials, should I always assume to leave a little bit of, if we've got a 1-inch piece of aluminum, is my part going to be, a tenth below that, or can I design a part based on that overall thickness of the stock? Does that question make sense?
It does, but typically designers don't worry about that.
Okay.
What we do is when it comes to the manufacturing programmer, what he'll do is he will actually choose a stock that is readily purchased. It's a known stock size, so stock comes in different increments. And he'll buy one that encompasses the part just enough, and then have it cut off on a bandsaw so that it's the proper length. So you buy aluminum billets like that, both height and width, and they come in like 48 or 60 inch long chunks, and you just have them, or you bandsaw it yourself into the proper length that you need, that ultimately leaves stock on all sides, just like you're seeing here today. So the facing operation is done, and it looks pretty good. It's clean. Really good finish on it. Really, really smooth. And now we've got a completely true and flat surface. So, which is going to be important for the next step. Because as nice as that was, the next step is a little bit more edgy. Okay, we're going to be doing a rough out. And the idea here is, again, to be aggressive, take a lot of material, but at the same time, don't let your tool wear excessively, okay? So what I'm going to do is I'm going to change out to a 1/2 inch cutter, and just give me 1 second.
So as John's going through, again, we got a couple of folks joining in. Yeah. Chris, good to see you as always. Mr. Mookley, another legend in the world of the CAM realm, is joining as well. Thanks for coming in, guys. As you guys, questions, comments, thoughts, just maybe dad jokes you want to share, all welcome in the chat. We're happy to have you. And you know what, if you're new here as well, make sure to subscribe to the Solidworks channel. We do these live designs once every other Friday, or once every other Thursday. along with a couple other, new kind of SolidWorks Live and the 3D exploring 3D Experience Works. We got kind of 3 reoccurring episodes we do throughout the year, all really fun. So to make sure you get those reminders, hit that subscribe button.
Hey, welcome, Michael. Glad to have you.
This makes me really want to figure out where I could lay a slab of concrete. Let's see, what would I have to do? Get a slab. I'd have to get the property to put the slab of concrete, to then build a pole barn, to then get a machine, and then I could start getting some chips to fly. So, John, I'm going to have my wife reach out to you this afternoon, and you guys can carry this conversation.
Sure. Absolutely. So here you can kind of see what our next toolpath is going to look like. And let's see if we can get it up here. Let's just go into the top view. So that's what the roughing toolpath is going to look like. And what we're going to do is we're going to use some high-speed machining techniques to get this done. So,
John, do you have the other part that's already been machined?
Oh, yeah. This one right here.
So kind of show us there what we're working on. So now we're going to be cutting out the...
We're going to be doing this internal rectangle that you see here. And then here in a moment, we're going to do these pockets after that. Okay. So we've got these internal pockets, and then eventually what we're going to do is we're going to do the external perimeter. And we do that last because we lose so much mass that it produces like a trampoline effect.
Oh,
so
interesting.
We want to do that last before we...
That makes sense.
Before we do any, as the very last thing, okay?
So, hey, John, I got a couple of questions for you coming in.
Sure.
Steve is asking about 3D Experience Works, and what does that contain in terms of properties for CAM? So I'm guessing they're wondering what's available today from the platform.
Well, I tell you what, there's an incredible role called the shop floor programmer, and that's what I use, and it's a great product. It does so much more things than what we're doing with SolidWorks CAM. It's much more capable. And then we actually have some more roles after that do things like address 5-axis machines, robotics, as well as complex mill turns, and even Swiss machines. And those are all things that we can't do with SolidWorks CAM.
And then another question for if you're just joining us now, John, do you want to go back and just talk about what we're actually making today? We got a few newcomers coming in.
Sure. This is going to be an iPhone holder. And the reason I'm doing this is the iPhone is going to sit in here. And when I machine away this carrier stock, we're going to have a camera screw mount here in the back so that I can connect this to any tripod. And the reason that we're going to do that is so that I can get some more live stream cameras here in the shop. So I want to utilize my iPhone. Just as you're seeing my iPad, right, with the machining here, that's an iPad. I'm going to add to my list of cameras a couple of iPhones. So we're going to have, like, instead of one pick here, we'll have multiple shots of the part being machined simultaneously. Okay, so that's what we're building.
One other question for you. And by the way, great tip on save your old iPhones. They make really nice little webcams.
Yeah,
so
they do. Exactly.
Machine your own case and turn it into that. Akash has got a question about how to calculate optimal load on the tool. And then we talked a little bit, but just to refresh on the criteria for selecting your feeds and speeds.
Yeah, so that always seems to be the number one question I get asked. And what I do is I always start with the recommended ratings from the tool producer. So the person who you buy the tool from, they have recommended ratings. And that's usually given to you as in the form of surface footage. What is this surface footage that I can run? And what is the inch per tooth load? And today I'm using about a 0.003 inch per tooth load with a 3 flute end mill. And I'm running about 700 surface footage during this rough out routine that you're going to see. Now, I'll be honest with you too. You can take the recommendations, but usually it's a little bit of trial and error. After you get those recommendations, you'll dial it in and you'll get a feel over time on what the metal removal rate is. So there's a formula that takes the diameter, the depth of cut, the radial cut. It takes all this information. What it actually does is it calculates a metal removal rate.
Yeah, see the MRR, right? Is the
That's correct.
You see that throughout, yep.
And you'll start to get comfortable with that. I actually put all my stuff inside of an Excel spreadsheet because that's where I'm comfortable. I can then use that data in any CAM system that I'm programming in.
And that's got to be material specific, I think.
It's material,
to state the obvious, but
material, believe it or not, tool and machine specific. A lot of times, like on this right here, I've got a 1 horsepower machine. I could obviously, if I had a 15 horsepower vertical mill, I could push this much harder and faster.
Sure,
okay,
that makes sense.
So it's all three, but the very first thing, you're right, is the material. That's the number one. Mm-hmm. So let's do this. Any other questions right now before we start the second tool path?
Nothing on this. Let's get you started. While you do that, there's a question about the difference between design on SolidWorks and CATIA. Maybe we can have our admins kind of cover that one. But let's get back into it because we're about halfway through, and
sure.
I want to see some more chips flying here.
You want to see some chips? Okay. Let's go ahead again. I'm going to go ahead and approach. Be careful, but I'm in a single block mode. I'm going to have to turn the coolant on at some point, but I'm going to start out with it off. And what we'll do is we're just going to single block this through. And you can see we're going to come over, start up the spindle, and we're now in an XY location of where I'm actually going to plunge. We're going to go ahead and come on down, and again, that 1 inch above the part is what I'm looking for on my digital readout. I feel pretty comfortable with that. That looks pretty good. That's just so you can see it a little bit better. What I'm going to do is take it out of single block mode and go to automatic cycle start, and we're just going to go ahead and start to run this job. The very first thing it's going to do is it's going to begin to do a very slow helix into the metal. And this helix, what it's going to do is it's going to use that as an entry cut to get down as deep as it needs to go into the metal. So helical entry is usually my favorite entry if I've got to plunge into metal. And you'll see it engage here in just a moment. And there we go. We're starting to cut some metal with that. And it's just going to helical down on in there.
Is that for tool life? Does that help with that versus just plunging it on in?
Plunging it right in sometimes can break your tools.
Yeah.
And it could be sound horrible, and it can stress your setup. So usually people will helix in or they'll ramp in at an angle, a ramp angle. Okay, so they want to do one of the two. So here you can see we're getting down there. Now after we get down to it, we're actually going to use some high-speed machining techniques to actually begin to take away the metal. And you'll be able to tell because it'll look very different. Everything sounds good, by the way, and that's another thing that we never talk enough about. The machinist ear. Your ear tells you so much about what's going on inside the machine and with the cutter. I can walk up to a machine in a machine shop and just listen to it for a second, and I know whether it's running good or not. And so do other experienced people like Michael Buckley on the phone call. He knows that very same thing. And others, of course, the rest of you who are also machinists, you know that to be true too. So we're just about down to the bottom of that helix. And if I do this, and look at the front right here, now you can see we're starting to take the metal out. Can you see the difference? And the chips?
Sure, yeah.
So what's interesting is that when we do high-speed machining, we take the tool as deep as it needs to go. And what we do is we take little side little step over cuts. And what this does is it improves your tool life and reduces cycle time, because first of all, the heat is generated, instead of being just at the tip, it's generated along that larger surface area on the tool. And when we eliminate heat, our tool life is much, much better. The other thing that makes this really good is that each feed rate is tuned for each cut that you see. So there's a separate feed rate for every cut, and this makes it very, very smooth. So I'm going to turn on a little bit of coolant.
So there's a question coming in from Shad on how Solidworks actually communicates your design to the machine. And I think we kind of talked about that a little bit earlier. There's a missing step there. Do you want to just go back and revisit, how do we hit print?
Sure. That's done after we create the tool pass in our CAM system, and whatever CAM system that is.
So SolidWorks, we have our design. That then goes into the CAM system. So we have that solid model.
Yes, I push it up to the 3D Experience platform, and it will open up inside of Shop Floor Programmer. And Shop Floor Programmer is what I'll use to calculate and create the tool paths. And then from there, those tool paths are actually, somebody said something about the coolant. After that, what we wind up doing is we run those cutter location paths that you've got on the screen. But we go through a post-processor. So there's a post-processing phase. It takes the cutter locations of the tool paths and then refines them into Gcode that's unique for each controller. And so
we have, go ahead, John, finish up.
Yeah, so the Gcode itself then is Gcode, the post-processor for this path pilot controller. This code that you see here has been customized by a post-processor writer who wrote a post to make sure that this data came out exactly this way, and that the controller likes the data, which it does. Now, there's another part of her question. I'm not sure if she was asking how I physically get the Gcode into the machine, but there's actually.
I think it was just on that. It was Shadi or Shad. Again, sorry about the name. Just going through, it's you design your model in SolidWorks CAD or whatever CAD system you're using. Hopefully, it's SolidWorks, and then from there, that solid body goes into a CAM software. John is using 3D Experience Works. It has the NC Shop Programmer. SolidWorks has a CAM software embedded directly into it. There's other flavors out there. From there, those machine or those softwares will know what kind of tooling you have available, know your machines, know your feeds and speeds, and will generate that Gcode automatically, which then we can then use to actually run the application. So hopefully that answers the question.
Yes, and that was good. The only other thing I'd add is there's a number of different ways that I can get it into the Gcode into this modern controller. One is, of course, these controllers will hook right up to your wireless network. So that's one great way, right? Another way too is if you've got like a USB flash drive and you want to use that, you can use a flash drive as well. Okay. Looks like we're getting a little bit of coolant on the camera. We're going to cut the coolant off for just a second. There we go. So great. This is going to run probably for another 5 to 10 minutes. So
all right. So good time. Had a good conversation going here from the chat. Looking forward, more questions, comments, thoughts. What are some of the experiences you guys have had machining? Shadi, I similar. For me is my mechanical engineering degree. I took a non-required class, but I wanted to learn more about these operations. because I think it's very important as mechanical designers, mechanical engineers, you understand how things are created. It's probably one of the largest constraints you'll run into. And if you don't know how things are actually machined and manufactured, you're going to design something that really has no life, right? It can't exist. So I went back, learned very similar processes, old school standard Gcode and manual machining operations, and it was awesome. I loved it. I wish I could do more of it. So totally agree. What else? Anyone else out there? Are you guys working as designers? I'm curious to know. Do we have any CNC operators in the chat, or are you looking to expand your education? If so, share your thoughts, share your insight and your background.
Yeah.
John, this is really cool. What is the typical manufacturing time would we be looking at then for this whole part from start to finish?
Well, if that's a great question. It depends on the machine. So on a really fast, modern CNC machine tool that you run production on, you could probably do this part complete under 5 minutes.
Oh, wow.
Yeah. Now, the Tormach itself is a prototyping machine. It's not meant to do production on. It's meant to create prototypes. And so it takes quite a bit longer. But this part here, to do everything, would probably be about 30 minutes. So there's a big difference. But still, if you've got in-house prototyping, 30 minutes to bring out an entire part, it's not too bad.
Right.
Especially out of aluminum. So the times will vary, but you can get it down really, really quick. Also, too, in a real production environment, you have a much bigger mill, and you'd also have multiple of these parts spread out on a fixture. You might have 12 of them, and you'd machine 12 at once.
Wow.
Okay, in one cycle. So that's the other thing. Prototyping.
We were chatting with Titan. I thought it was really interesting to learn about custom fixturing.
Yeah.
And what can go into that. So, you have maybe a military contract, whatever it might be, and you might spend a lot of time designing a fixture to be able to do it in a single operation versus a 2 or 3 step operation, which is fascinating.
It is fascinating. In fact, that's another whole avenue that we don't discuss much about NC programming, and that is fixture design, because they go hand in hand. There's really 3 main areas that an NC programmer will get pretty good at. One, of course, is programming the different machine tools, but another is process planning, understanding the recipe and the flow of how this part moves through the shop, the different departments, and also how many different stages it's going to take to make it. On this machine, there's going to be 2. On a 5-axis, it would probably be 1. So process planning is very important. And then finally, fixture design. Because you're right, you can be a great NC programmer and a great process planner, but you're not going to make much money if, for example, you're just doing one of these parts at a time. I think we're getting a little bit of coolant. So really, it's really critical that you really do a good job with fixture design and you understand how to do it. And it's one of the funnest parts of the job. It's what makes you sink or swim in the business.
So this is how we look at, I'll just use Tesla as an example, because you hear about them always refining their manufacturing processes. And
Sure.
That's really how they can bring the price down, or even in iPhone. I guess the iPhone prices are going up, but you have something that 10 years ago may have cost a lot of money. Over time, as you refine processes, you shrink down that manufacturing, that chain of handoffs and machining operations and custom fixturing and new
Right.
technology. You can reduce the cost, and at the end of the day, that makes everyone happier, right? Bigger margins, more customers, and so on. So all those steps you mentioned are super important. The design obviously is important. The design aspect, understanding how that will transition into the whole workflow to the consumer is it's critical. Yeah, that's interesting.
Yeah. In fact, to be totally honest with you, I have more fun in doing the fixture design and doing the process planning than I do of just the actual NC programming portion of it, because it's that That's where it makes you or breaks you. That's how you become competitive or not. Is in your fixturing, how many you've got, the automation that you're using. Are you loading your fixture with a robot? Is it a palletized system? Those are really what make you competitive.
John, we got two other good questions in for you. Don's got one. He wants to know what speed are you running with your volume mill on your aluminum part, and how much percentage faster are you running with volume mill versus traditional roughing?
Okay, well this is more of an adaptive concentric, which is very similar to volume mill. It's just, but I am running right now. It's a 1/2-inch end mill, Don, and I'm running 5,500 RPM, and my program feed rate is around 50 inches a minute with this 1/2-inch end mill.
Do you know how much? Yeah, the speed, the percentage faster you're running with the concentric end mill, I guess, than traditional roughing.
This would actually probably be probably give me a 4-to-1 time saving, 3-to-1, 4-to-1 time saving on this particular operation by going to high speed. Mm-hmm.
And Kieran's got a great question. What is the most difficult task in CNC coding?
What is the most difficult task? I would say probably learning the software well enough to where you can get the exact type of tool pass you're wanting to machine the feature that you're trying to machine. So the most difficult thing is to really knowing the software really well. Okay.
Makes sense. That makes sense. I'd be curious to see some of the other experts out there, Jason, Mike, your thoughts. What were some of the more difficult or most difficult things in your experiences of just CNC operations? Where do you run into the biggest struggles? I want to see what you guys think as well. So throw that out there.
And I know that Michael and I work closely together, so we're bound at the hip on a lot of this stuff. He's got some good insights too.
So John, how long have you been running a CNC machine? When was
That's awesome. Actually, I started in high school.
Okay.
And we were fortunate enough that we had high school, and our Plano High School had a machine shop as well as an automotive shop. So we were able to take those in our junior and senior year. I did it. And what was really interesting was because I live in Texas, right as I got out of high school and started college, the oil and gas industry exploded. And all of a sudden, Halliburton wanted to hire me and wanted to pay me an awful lot of money. And I told them, no, I'm in school. And they said, well, no, hold on. We'll put you on second shift and we'll pay for your college. You come to work for us. And we will train you on our machines. And they did. And yeah. So it had a happy ending.
So as a design engineer, how would you recommend learning this? I mean, you learned in high school, which is awesome. And unfortunately, that's a dying thing we see, at least around my area. But what's the best way to really get started?
Well, probably the best way to get started is to probably go to a specialized technical school. And we work closely with some of those. One of those is up in Colorado. It's Cherry Creek Innovation Campus. And they are incredible. They've got all of these machines. And I actually work very closely with the instructors. I'm probably on the phone with them once a week. And it's a great place to start out to learn. And they prepare you for the industry. And you get a little bit of everything. You get design, you get operation, you get CNC programming, you get process planning, and you get fixture design right there, usually in a 2-year degree.
What's great about the 2-year too is that you have the hands-on, and you mentioned a few things like the machinist ear, something you can't learn necessarily from YouTube videos or an online type curriculum. being there, being around the machines, seeing it, feeling it really does make a huge difference in terms of, your learning path. The one I will mention though, if you want to dabble and start to learn a bit more, check out Titans of CNC. They have an academy online on their website that will get you into some of the back end programming and how to kind of get a little bit more involved there as well. So we'll give Titan a plug because we love Titan, but check that out as well if you're looking to. So we have another question. Looks like Nalamasu, I think that's how we say, how can I learn CNC coding by visualizing the process without having a CNC machine?
You can do that, and you can learn the actual software that creates toolpaths. But in the end, you've got to be able to take, and the tricky thing is the depth of cut, the surface footage, and the feed rates. You've got to actually, to get really comfortable with that, you've got to actually put it on a machine and run it. I wish there was an easier way to say that, but there's really not.
It makes sense. It makes sense.
You just have to, and slowly but surely over time you get a feel for it. It's almost like another sense that you'll develop, and you can begin to get very close. And know what's going to happen when you do your feed speed selection and your depth of cut. You almost know ahead of time based on your experience at the machine watching it cut.
It's kind of like I'm pretty fast in Gran Turismo on my PlayStation, but put me in an actual Formula One car and it's probably not going to end too well. So
yeah, you probably learned some good tricks on Gran Turismo, but in the end, you got to get in that car and you've got to get a feel for it.
The hands-on, the feel, the actual physical experience is important.
Yes,
that's for sure. I got it.
So let me blow this off right here, and you kind of see the rough out on it. And there at the beginning of this, we started out with just a billet, and now we've got it faced off, and we've got that rectangle cut done in it. And now what we're going to do is we can come back and we can add these pockets. And then eventually we'll go here and we'll machine the perimeter. I'm not sure how much time we've got, though.
We got about 5 minutes left. I think we could probably go over a hair. One question we missed, too, is while we're kind of going through is any recommendations on books, just acknowledging from, do you have any like machinist hand guide or handbook or?
Well, I wouldn't start at the machinist handbook.
Okay.
Just like I wouldn't tell you to be an engineer by picking up the engineering handbook. But probably a good book for this would probably be, jump on Amazon and just, introduction to CNC programming or, CNC programming for dummies or something like that. Not that anybody's a dummy, but it's just that brand of book. Go out there and take a look at that because they've got some that will really explain the concepts to you. And believe me, there is a lot of book learning that you can do before you actually come and get on the machine or before you start to run CAM software.
Mm-hmm. Yeah, always good to have a good foundation going into any type of curriculum. If you're looking at doing a technical school, a technical trade, having that base lingo, base knowledge, that way you're prepared to ask the right questions and you're not going in blindly. And that's just a good rule in general with anything you do in life.
Sure it is.
So great question on that. And check out like a local bookstore too. They might have some used books and I think available as well.
Right.
On some of this. So great question. But yeah, I think we all agree. Well, let's go a couple 5-10 minutes over and see what you have next for us, John. I'm excited to see.
Oh, okay. You want to do some more machining?
Sure.
Oh, okay. Great. Yeah, let's do that.
John, I think we have a request for you to write a book with all that spare time that you have these days.
Actually, speaking of writing books, Michael Buckley, who I work very closely with, has written his own book. He's an author, and
I didn't know
a lot more. But Michael wrote the book on SolidWorks CAM. So just to let everybody know, if I had, I may even walk into my library and go get the book here and flash it. But yeah, he's you can definitely write books about this stuff because it just takes so much different knowledge and you can wrap all your experiences into it. And for somebody like me, especially at my age, I love to share and give back this knowledge, especially to the kids, you know. So I may write a book someday. Who knows? Okay.
Well, if you do, I would love an autographed copy for my office.
Absolutely. So what I've done is I've gone to a 1/4-inch end mill because these pockets are pretty small. So we've got to get into the pockets. What we're going to do is we're going to call up a new program. And you can see now if we zoom in on this, I don't know if you can see it. But you can see all these little pockets that we're going to machine.
John, we got a question. We mentioned the Tormac before, but what model Tormac are you running?
Ah, that's a great question. So I am running a PCNC 770 with a Path Pilot controller.
Okay.
And it's a 10,000 RPM machine, 1 horsepower. It is fantastic at cutting aluminum. Okay. Okay. So you can also cut harder materials too, tool steel and other hard materials. It just takes longer, but it does an exceptionally good job on aluminum. Okay. So let's do this. Let's go ahead and let's start the machining of these pockets. Okay, we'll get that going. So let's do this.
You know, going back to you're mentioning in high school, my dad, who graduated from Hibbing High School back in the early 50s, and they had a similar operation. They actually had a steam engine to work on.
Really? A steam engine?
Yeah, full-size steam engine in the high school, and they were able to
that's
work on
incredible.
that. Yeah, it was just a beautiful school, massive industry, and he's a big believer, in the trades and learning, you know, those 2-year degrees, technical degrees. Even today, we still need hands-on machinists. So if you guys are looking and considering a career path, a career choice, definitely, I mean, CNC machining, phenomenal, make good money, and you do some, I mean, you're going to do this all day. What can't go wrong?
You can't. So I'm going to turn off the coolant because the pocket itself is actually going to trap the coolant inside of it. And so I could just let that lake that's formed there in the pocket keep my tool very cool. So we've got a lot of little pockets to do. You can see up here, we can actually begin to track the actual tool motion. And you can see it going through the code, I think. I hope you guys can see that. So this is the part that's going to make those pockets come out. And these are really lightning pockets that'll lighten up the part and to add a little bit of design to it as well. Interesting design.
So John, a question in here about a ball tool. What, you know, we're using, we had that flat end mill before. Mm-hmm. When would I switch out to use a ball tool?
Well, ball mills are great for doing very complex surfaces that move in X, Y, and Z. And the reason that we use a ball for that is because the ball can cut that out really smooth, where you couldn't get it smooth with a flat end mill.
Okay, makes sense.
So we see on all these swoopy surfaces, especially things that you see inside of a mold, you know, there'll be a lot of ball mills used there. I'm getting a little singing too. Let's do this. It stopped. But sure, that's when you use a ball mill. Mm-hmm.
And the pockets here, is this purely aesthetic that we're cutting them out? Rate reduction? What's the...
It does both. It's weight reduction, but it's also aesthetic in the fact that I've I've made the cutout pockets very. There's a design aspect to it, an artistic aspect to it that I
Sure.
did for the pockets, rather than just put in just straight ribs, right? Or just normal pockets. We did something that was find the part. It's a little bit more artistic. I don't know if you can kind of see that. It's almost like it's almost like there's a
Yeah, I see it. Yeah.
yeah, it's almost like it's a neuron pathway or something similar to that. Anyways, it's going to look cool. And what I'll do is when I get finished with it completely, maybe we'll come back and do another design live, and we'll go over, what we do with it.
Sure. Yeah. For the audience out there, John has a bit of an artistic background, so he's going to add a little bit of his signature to anything he designs or machines, manufactures. Right. Hey, we got another great question. Akash came in. He said, "What are some reasons for tool breaking, and how can you avoid that?"
Well, you know what? The number one thing about tool breakage is to know your proper speeds and feeds, and that was, that's one of those things that I mentioned earlier. You get the recommended settings from the tool manufacturer, and then you kind of tweak those settings for your machine and your depth of cuts and some other things. But that's the number one thing is getting those completely wrong or very wrong will break a tool. Another thing that'll break a tool is if you let it wear too much. Usually your ears will tell you when you're at the machine tool, the tool is wearing. Another way that you can tell is when you can take your measurements after you've machined a part. If the measurements are starting to get larger or smaller, you can tell that your tool is wearing.
And that's where you get into a good QA process can actually statistically measure and see that change in your geometry, and you should investigate. It might be the fixture, it might be the tool. We learned that within Solidworks inspection and working in QA groups. So that's a great point.
Yes.
A couple other questions. A lot of questions coming in at the end here, which is awesome. I love this question because I have the same one. So I'm new in this case. Shad's he's in college, maybe a smaller budget. What's a smaller scale machine maybe we could look at to start getting hands-on experience in CNC? One you're familiar with, and
if you're going to purchase one, I highly recommend the Tormach, the very machine that you see me using now. And they're incredible entry-level machines that will teach you all phases of being a machine operator, of being a CNC programmer. You'll be able to do everything, just like you saw me earlier, run a probe, right? Probing to find X, Y, and Z is kind of an advanced functionality on a lot of mills. But again, Tormach supports that, and the controller is state-of-the-art. It's a Fanuc dialect, and they're just great. You can get them new, and I believe there's a little bit of a wait right now. I've got a few friends that are actually on this call today that are looking at purchasing one.
Okay.
You can also get them out there on the used market at some really good prices.
Is that I do a lot of photography. I always buy kind of professional level equipment, and I typically buy used, knowing that pro level users take care of their gear. Would you say the same? And you don't have to answer this if you're not comfortable, but
what's really
same thing with machining?
It's really interesting. I saw a little bit bigger version of this, a Tormach 1100. That was circa 2017, which is what mine is. And it had somebody that said, come and pick it up. It looked like it was in great shape. It was $10,000.
Okay, yeah. And that's probably, you could probably turn that around and pay it off pretty quick.
Yeah, and now again, you can get a lot of small desktop machines just to learn on that are much, much cheaper. And there's some good ones. There's even some nice 5-axis desktop machines that you can get for $6,000.
Yeah, it's not bad at all.
No.
So John, how much longer do you think we have on this tool path? I think we'll start.
Oh, we've got a little bit. We probably
Okay.
we probably have another 15 minutes.
Okay. All right. Well, we won't wait that out. I think so far this has been one of my favorite live designs. We appreciate the time. We went a little over, you guys. Thanks for sticking around and asking a lot of great questions. Let's do a quick poll if my admins are there. Do you want to see another live design with John where we get into machining? Yes or no? I know what the answer is going to be, but I want to prove it. I want to prove how exciting this was. So give good feedback to John. John, we appreciate the time. I learned a ton. I had no idea the importance of that first process. I guess it makes sense, but that you could actually really wreck your tool, when aligning up to 000, or was it G35, G34? No place like home.
G54.
G54. Mm-hmm. There we go. No place like home.
And G53 actually takes the machine tool home.
And that goes back up to it's 000 coordinate system.
Correct.
That's fascinating. What I also loved, and this was something that came up kind of on a smaller side, but I never would have thought about the trampolining effect, making sure you have rigidity in the part throughout the process and leaving that to the end.
Come to the shop floor, and you're going to see what we talk about, the scene or the trampoline effect, because we're going to be running a D&M 200. It's a 4+1 machine. But what we do is we use tabs. And we'll machine it on a 5-axis, so there'll be tabs in there. What happens is it's just like this. They're thin tabs holding the part. And as you finish machining, it'll start to bounce, and it'll be a trampoline, and it'll make some crazy noises. It'll sing.
Okay. Sure.
So we hope to avoid that, by the way. Hopefully, if we do it right, you won't hear any of that. But be sure to come to the shop floor.
So the shop floor, let's plug that 3D Experience World coming up in Atlanta. Yeah.
Michael Buckley and I will be there running Doosan machines, and Michael's going to be programming and running a 5-axis, and I'm going to be running a specialized Doosan mill turn. It's actually got 9-axis on it, so it's a beast. Oh, we're going to have some fun.
If you can't make it live, we are doing a hybrid event this year, so there's still going to be streaming events online. You can check it out. We'll get the link to 3D Experience World in the chat, so make sure to check that out. And right now, they're running a promo on it. We're starting our Black Friday sale on it now. Super fun event. We're really excited to get back in person with everyone, say hi, see everyone. Check out 3D Experience World. Also, if you want to watch more of these episodes, if you haven't got a chance to subscribe to the channel, please do. We appreciate your support. The more subscribers, the more we know it's you guys love these, and we love doing them. Hey, John, any last minute thoughts you have or want to share on today's?
Only that thank you for having me as a guest today. I'd love to share information and the knowledge that I've learned over the years and have been shared with me. So it's always good to give back, and it was my privilege to be here today.
It's been an honor working with you. Your depth of knowledge, and it's great to have you around. So we'll definitely have you back. And with that, I think we'll call it a day. We'll let the machine run. Some chips keep flying. Guys, thanks for tuning in. Looking forward to next time, and we'll see you then.
Thank you very much, everybody. Have a great day.
See ya.